Hello, this is Mr. Miller, and it's time for video 5A. In this video, we're going to talk a little bit about the characteristics of parabolas. And we want to be able to describe all the different features parabolas have. All right, well, as usual, we have a few examples here. So let's take a look at the first one. So for this problem, we're actually going to practice completing a table and graphing the parabola. So this is a very important skill, and the first skill we're doing in this part of the unit. So pretty much we want to substitute these values of x into this equation and find the value of y, and then we're just going to plot that. There's one thing we always have to be careful of, though, is that when we square negative numbers, we should use parentheses. Okay, so let's do this first one. We're going to substitute -4 in. In the workspace, I'm going to write very carefully what we get when we just substitute -4 into the equation. So this minus is in front, and so I have a minus in front. We're replacing x with parentheses -4, and we're squaring that, and then we have -4. I'm going to put in parentheses again -4, because that's the value of x, plus 1. All right, so I'm being really careful how I write this, putting parentheses around the x value. Okay, if you do that, you can just enter this into your calculator, and it'll give you the correct result here. And it turns out all of that ends up being 1. Okay, let's substitute -3 in. So we're going to do the same thing. Wherever I had a -4 for x, I'm going to put a -3. -4 times -3 plus 1. If you're using a calculator and you entered the first expression, all you have to do is cursor up and modify what you had. Just put -3s where you had the -4s and hit equals. All right, so this part is -9, and that's going to be plus 12. That's 3 plus 1. I believe we get 4. All right, let's put in -2. Minus, parentheses, -2 squared, minus 4 times -2 plus 1. This is going to be -4 plus 8. That's 4 plus 1 is 5. All right, and we can do the other ones similarly. That ends up being 4, and 0, the easiest one is last. We don't need parentheses around 0. Well, this one I have to write it as multiplication, and then plus 1. We end up getting 1. All right, now we're going to plot them. X is -4, y is 1. That would be right there. When x is -3, y is 4. So that point is there. -2, 5 is here. -1, 4 is here. And 0, 1 is right there. And we can see the shape of a parabola. We see a U shape developing. I'm afraid I'm really going to butcher this, but I'll try my best to draw this with my digital pen here. Oh, I missed that one a little bit. We would draw in a smooth U shape. And I'm really sure you can do a better job with that using paper and pencil. But that's what I can do using a digital pen, but we kind of see it. It's an upside down U. Now, if you can evaluate this one, I think you can evaluate any of them, all right? It's just being really careful with the parentheses and the negatives. All right, well, we're going to move on to a little happier example here. We're just identifying information in the graph. But all of this is really important. So the first thing about the graph we want to identify is the vertex. The vertex is simply the point where the parabola turns around. So this parabola is going down and then turns around here and starts going up. That turning point, that's what we want. So we're just going to write the coordinates of it. Well, the x-coordinate is -1 of that point, and the y-coordinate is -4. Vertex is important because later when we're making graphs of these, it's important to know where the vertex is, and that helps us draw a graph really quickly. All right, what's the domain? Well, we went over this. This is not a new topic, but maybe we need a reminder. This arrow right here in the parabola means it goes forever to the left and forever up, right? It's going to the left and up. And this arrow here on the right indicates that, well, the parabola is going up and is going to the right forever, right? Parabolas never go straight up. They always kind of go diagonally up, or they have a slant to them. So now when it's asking the domain, we see that this parabola goes all the way to the left to negative infinity. It keeps going to the left, and similarly, it keeps going to the right. So we can write this as an interval, all right, from negative infinity to infinity. We could also write this as an inequality. That means all x values that are between negative infinity and infinity, which is really all the numbers on the number line. Okay, now a little reminder, the range is how low the graph goes to how high. Well, the lowest point here is -4, and the graph goes up to infinity. It keeps going up. There's an actual point that has a y value -4, so we're going to use a square bracket because it includes that value. And we always use parentheses with infinity. Now, if I'm going to write the inequality, I could kind of start what I'm did before. But there are two things here. One, we should realize this is a square bracket. That means that, well, first of all, I should be using y. So let me fix that. So we're talking about y values. But since this is a square bracket, it should be greater than or equal to -4. Now, we actually don't need this less than infinity here. It's not wrong, but all we really need to know is that y is greater than or equal to -4. It's going to be less than infinity if that's true. So we're just going to kind of rewrite this like that. Okay? But that's really about inequalities and intervals, not about the graphs of parabolas. All right, next thing I want to talk about is the line of symmetry. Parabolas have symmetry. You could fold them in half, and they perfectly overlap themselves. Well, first we want to know the vertex. So the vertex is right here at, looks like 3, -6. So +3 and -6. And the line of symmetry always goes right through the vertex. So in this case, the line of symmetry is a vertical line, which I kind of drew sloppily, but if you notice, every point in this line has x-coordinate 3. It's a vertical line that goes through 3 on the x-axis. The equation for a vertical line like that is very simple. It's all points with x equals 3. This is 3, 0, 3, 1, 3, 2, 3, 3, 3, 4. Any point that has x-coordinate 3 is on that vertical line and satisfies that equation. All right, this one has a horizontal axis of symmetry. All right, the vertex is at -1, 2. The line of symmetry goes through it, but it's just horizontal. Every point on this line has a y-coordinate equal to 2. So horizontal lines have equations like this, y equal to every point with a y-coordinate 2. So a line of symmetry is pretty easy to find in the graph, and what you have to get used to is writing an equation for it. Equations for horizontal lines and vertical lines are very simple. It's x equals a number or y equals a number. All right, this is our last example. We want to quickly talk about a couple other things here. But first, we'll identify these points. So this is getting kind of old news here with the vertex. X equals 3, y equals -4. That's the vertex. Y-intercept. The y-intercept is where a graph crosses the y-axis. And what they want are the coordinates of that point. So any point on the y-axis has x value equal to 0. Then we just got to put the y value of that point, which would be 5. All right. Parabolas may or may not have x-intercepts also. That's the points where they cross the x-axis. So this one has 2, and they're kind of nice. And they can be decimals and nasty, but this parabola is a very well-behaved parabola. So it has one x-intercept at 1. So the x-coordinate of that first point is 1, and the y-coordinate is 0. The other x-intercept is at 5, 0. Crosses at 5 on the x-axis. So those are our 2 x-intercepts. So given a graph, those aren't too hard to find. And if we use something like decimals, we can just click on it and it'll tell us the coordinates. And so it's kind of nice. All right, well, I want to erase that to make some room for the next part. We want to talk about the domain and range again. So that we're familiar with. This parabola goes all the way up to infinity and all the way to the left. And on this side, it's going to go all the way up and to the right also. So the domain would be from negative infinity to infinity, and they just ask for an interval. Well, for the range, the lowest point is at y equals negative 4, and it goes up forever, so that's going to be from negative 4 to infinity. All right, now we have something a little new, and this is a quick introduction to it. We want to know for what values of x is the graph increasing. So again, let me clear up the clutter a little bit here and erase a couple things. But over all the values on the number line, for what values of x are the y-coordinates going up? Well, the important thing to do is look at the vertex here. It's right here. It kind of divides the parabola into 2 halves. On the left side, the parabola is kind of going down. It's decreasing. On the right side of the vertex, it's going up. So I'm going to draw a little mark here. That's actually on the line of symmetry, and that's the vertical line that goes through the vertex. For the values of x on the left, for these values of x here, all the way up to 3, the graph above those or below those is decreasing. So as long as we are over here going up to 3, the graph is coming down. All right, this is something we're maybe new. Once you get what's going on here, it's going to be easy for you. And we're going to have to practice this more in class. But it's asking for intervals on the x-axis where the function is increasing, decreasing. Well, it's going down until we get to 3. So the decreasing part would be from negative infinity to 3. All right, these are the x values, which the graph is going down. All right, on the other side, these are the x values where the graph is going up. The graph starts going up right here, and it's going up, up, up on the right side. It's going up for values of x that are greater than 3. So the interval where the function is increasing is from 3 to infinity. Okay, we're doing really good. We're going to get that. So we just need more practice. All right, finally, the line of symmetry is like what we did before. That goes through the vertex here. So again, let me clear up my mess here. And let's see if we can illustrate that a little bit better. I'm even going to use the line tool in Canny. And the line of symmetry would be right there, almost. So it goes through 3. Okay, well, it's vertical, and it goes through the x-axis at 3. So the line of symmetry is x equal to 3. All right, we're at the journal assignment. Good luck.